Okay, dear students, so welcome to the new video. And in this video, we are going to talk about the horizontal circle. We learned about the circular motion as such in journal, like we learned all the formulas. We learned about the centripetal force as well as the centrifugal force. And today we are going to take one very particular example in regards to horizontal circular motion. And we're going to learn many things on this. Just a moment. Yeah. Yes. Yeah. So this is called the turning of a vehicle, and in this case, like this is one of the examples of the horizontal circular motion, in which the vehicle is going to turn around on a road. So this is the road, and the vehicle is turning like this. So we all know that whenever the circular motion is taking place, it cannot happen just by itself. There got to be there the centripetal force. Otherwise, the circular motion is not possible. And what is the centripetal force? The centripetal force formula is mv square by r. So mv square by r is the formula for the centripetal. Until unless there is this force, the circle is not turning. But as I've already told you in the earlier video, that centripetal force or the centrifugal force, both of them are not the real forces. They are fictitious forces. Or I must say that some or the other real force must be acting like centripetal. Centripetal force does not have its individual existence. Okay, so there has to be one force which would be acting like centripetal, and due to which the body will start moving in the circular fashion. So this body is now moving in a circular fashion there. So there is a force which is acting towards the center, and we don't know which. We have to find that. That force is acting like centripetal. Now, what is that? Now, this is the example of a car which is moving. So, while we want this car to turn, what we do, we just turn our steering. So, what happens there? Because of the friction, the car is turning. Let us say there is no friction between the tires and the road surface because of some oil or some water or some kind of skidding is taking place there are so many reasons, isn't it? So because of some reason there is less friction there. So even if you are turning your steering, even then the car will not be turning. So car is turning because there is friction. So friction is the force which is responsible for the turning. So we have to find the friction. Now, if let us say it is not turning, so it would be going in the opposite direction like this. So it would be skidding in that direction. So we can clearly assume that yeah, the friction is acting in this direction, which is preventing the car from skidding, which is preventing the car from moving away from the circular trajectory that is drawn there. It is not able to increase the radius. This is what we mean to say. So what is the friction? So I'm taking fs max, but although we have yet not completed friction force, like what is friction, we don't know it as of now. So that will be completed in the laws of motion topic. But before that, we will see that later. But anyways, fs max can be taken as mu s m into g, where m into g is the normal reaction for the vehicle. So this is the vehicle here, and this is the weight. So this will be the normal reaction r, and this is the frictional force. So we can say that the friction will be mu s into r, and r will be equal to the weight. So that is why it is mg. So this is the frictional force which is acting towards the center of the circle, which is acting like centripetal force. So I can equate these two forces now, which means that our equation will become m and m are getting cancelled out. We want to find the expression for velocity, let us say. So velocity is coming out to be mu s g r square root. So this is the velocity, and this is actually the max velocity with which the vehicle can negotiate the turn. If the velocity of the vehicle is more than this, then definitely skidding will take place, because our friction force will be lesser than the centrifugal force. Here I must say that it is centrifugal force. So I would be coming to that point, but just let it be for this time. So the V max is coming out to be mu sgr. Now, in the last video, when we were discussing about the centripetal force and the centrifugal force, I told you that centrifugal is like, you cannot write it in IB examinations, but it's very useful to understand. Now you see the application of the centrifugal, but although it is not given in IB, and so it will be better if you actually do not talk about the centrifugal force, but just as a student of physics you must know it, because it is very very usable. Its utopian value is very high. Let me show you that. Now if I ask you why the car is skidding, and why when it is skidding it is going away from the center, or it is increasing the radius, there has to be a force, isn't it, like which is pulling the car to the other direction, isn't it? Now that force can be regarded as the centrifugal force. And what the theory that I gave you is that we would be imagining two forces. This is centripetal and this is centrifugal. So the if I talk about like why the car is able to turn around, why it is moving in a circular fashion, I will say it is due to centripetal force. Centripetal force is the force due to which it is turning this. But why it is skidding, why it is going away from the center now? It is because of the centrifugal force. Because let us say I increase the velocity with which the car is moving. There are two forces here. Just a moment, please. Like there are two forces here that we are comparing. So the first one is mu s mg, that is the maximum possible friction, and the other force is I will say centrifugal. Now I'm considering centrifugal force. Let us say this is the force which is going in the outward direction. So if I say that friction is more than centrifugal, friction is more than centrifugal, so friction is acting like centripetal, isn't it? So the car will be turning around this in a very easy manner. But if I say that no, the velocity is more than the maximum permissible value, so the clearly centrifugal force is becoming way more than what is friction. So friction cannot provide that kind of centripetal force, and centrifugal force becomes more than the friction. Clearly this outward force is more than the inward force, and that is why car is getting skidding. That is why the car is skidding. It is going away, it is going away from the center, and the radius of the turning is increasing, isn't it? So this is how we can explain this. So there are two phenomena that I have tried to explain you here. I believe that should be clear to you now. Number one is this thing, that if like we are just considering the centripetal force, or you consider the centrifugal force, by the way, the V max is coming out to be equal to square root of mu s gr. That is the maximum velocity with which the car can negotiate the turn. If you are having a velocity more than this, it is definitely going to skid. And the second thing is the concept of the centrifugal force, which is quite kind of, it's very, I don't understand why IB does not want to teach you centrifugal forces. So we will not be talking about it. But yes, I have tried to explain you the same phenomena with the help of centrifugal force. There will be another question that I will show you for the horizontal circular motion only. If you do not consider centrifugal, it will be very difficult for you to actually understand what is happening. I will show you that in the next video. Okay, so this is it. In this, we have found the Vmax, but now let us go for one question there. So the coefficient of static friction between the tires of the car of mass 1100 kg and the dry asphalt is about 0.8. Determine the maximum speed with which the car can turn the circular this with 95 meter as the radius. Okay, so I have given you the formula already. Let us go for the application part of it. So the velocity, as we have already seen, the maximum velocity will be given by mu s into g into r square root. So the mu s value is 0.8, g will be 9.81, and the radius is given as 95, and we take the square root of that, and directly you would be getting the answer for this. So let's see, 0.8, 9.81, and multiply by 95. So it is 745, and we have to take the square root of that. So square root of this is coming out to be 27, and so in this case our answer is 27.3 meter. Clear cut, it's a very short numerical, it's a very easy numerical, so we can just substitute the values if you know this formula. If you do not know this formula, you have to use the concept. I have already given you the concept now, so let us verify if this answer is correct. Yeah, just a moment. Yes, 27 is the answer. Now, in the wet condition, the coefficient of friction is reduced to half its value in the dry condition. Predict the safe maximum speed now. So again, we would be using the same formula, but in this case, the coefficient of friction is now half, and this is the V max that you can the vehicle can have now. So it is 0.8 divided by 2 is 0.4 into G into the radius will be 95 still. So this will be our value clearly, like we can solve it. So this is a very important example for the horizontal circles. So we cannot ignore this. 19.3 is the answer. So now the answer is coming out to be 19.3 meter per second. So clearly earlier when it was a dry day, the vehicle could be having a velocity of 27 and it can negotiate the turn without skidding. But when there is some kind of rain is taking place or some water is there on the streets, so you can clearly see the velocity is reduced to 19. So that is why usually what people do is like we just assume that okay, on this turn I usually move with that kind of velocity. In the rainy days also, like they keep on moving with the same velocities, and that is why uh, people skid in the rainy days. Okay, so yeah, this is a very good example now. So this is one good example for horizontal circle. Now I would be showing you another very important example for the horizontal circle in the next video.